Good morning, everybody. For the diploma first years chemistry, I am Prakash, lecturer in chemistry, JPT Nirmal. For the second semester students, electromotive force or electrochemistry part 2. In this chapter, in the previous class, we have discussed about the what is a cell, how can we are represented the cell and galvanic cell. So when we have to take the two electrodes and make a cell, in that cell we generate the power. How it is will the generate the power when we have to two electrodes are connected each other. So now we have to discuss about the EMF of a cell. So when we are using two electrodes, cathode and anode, at cathode one type of potential energy, at anode another type of potential. So between two different potentials is called as EMF of a cell, electromotive force of a cell. That electromotive force only giving the motivational energy to moving the electrons from one place to another place. By momentum of electron, the energy will be generated, which is called as electricity. So due to the EMF of a cell, the energy will be released, that is called as electricity. So definition of EMF of a cell: the potential difference between two electrodes of a galvanic cell which causes flow of electrons is called as electromotive force. The force with which electrons are pushed from anode to cathode is the galvanic cell is electromotive force. So, what is there going in the galvanic cell? The force with which electrons are pushed from anode to cathode in the galvanic cell is electromotive force. So which force will be pushing to the electrons from anode to cathode? That force is called as electromotive force. So the potential difference between two electrodes of a galvanic cell which causes the flow of electrons is called electromotive force. how can we calculate that force? The electromotive force of a cell can be calculated from the electrode potential values. Suppose we can take that the total cell is represented in the capital E cell. Electromotive force of a cell, we have to represent it in the form of E cell. That E cell we have to calculate it from the, in previous class we have to discuss about the reduction potential, oxidation potential. So whatever there, the reduction potential is equal to oxidation potential at quite opposite. So for every electrode have the how much reduction potential is there, that much quite opposite, but that much amount of oxidation potential also is there. So here we have to say it about that E cell is equal to reduction potential of cathode minus reduction potential of anode. So otherwise E cell is equal to E cathode minus E anode. Or E cell is equal to always be cathode at right side, always be anode at left side. That's why ERHS right hand side minus ELHS, where RHS right hand side electrode, left hand side electrode. By this formula we have to calculate electromotive force of a cell. When we know the reduction potential or oxidation potential of two electrodes, either cathode or anode, then we have to calculate the motive force of a cell, electromotive force of a cell. So E cell is equal to, otherwise again reduction potential of cathode, if we know the reduction potential of cathode, then plus oxidation potential of anode also. Why? Because here differences between reduction potential of cathode minus reduction potential of anode. But here if you take the oxidation potential, so how much reduction potential is there? Quite opposite of the oxidation potential. Then you have to take the minus, then minus into minus plus, then you have to take the formula electromotive force of a cell in the form of reduction potential of cathode plus oxidation potential of anode. So EMF of the cell, if calculated from standard electrode potentials, then it is indicated as E naught cell, standard electrode potential. What do you mean standard electrode potential? When we have to standard properties, we have to maintain in the solution. Suppose molarity means nothing but concentration, temperature, definite amount of volume. Then that is the standard solution. For the standard solution, standard EMF is there. That standard EMF of a cell we have to represent it with E naught cell. A cell with the positive value of EMF only generates the electricity. If we get the EMF of a cell negative value, then it will be not generate the electricity. So when we have to observe the numerical problems on EMF of a cell, problem when we have to take the SRP means what do you mean? Standard reduction potential of magnesium and cadmium. CD means cadmium electrode is, so here magnesium standard reduction potential is minus 2.37 volts and cadmium CD electrode SRP standard reduction potential is minus 0.40 volts respectively. Calculate the EMF of the cell. So here cell representation is magnesium oblique 2, magnesium plus 2, and two slides cadmium plus 2 slash CD. So this question is asked in March-April 2014 for the civil, March-April-May 2011 also for the civil. So this is a very important problem. You have to remember the solution for that problem is in this cell. How can we have to represent the cell? Mg gives to Mg plus 2, and the double slash is represented the salt bridge. I have already discussed in the previous class. Double slash is a salt bridge. So cadmium plus 2 cadmium. Single slash represented the one of the electrode. So here magnesium electrode and cadmium electrode. At magnesium electrode, which reaction is going to be? At cadmium electrode, which reaction is going to be by representing the our electrode. So we have to decide the which is the anode, which is the cathode. At anode, which reaction is takes place? At cathode, which reaction is takes place? So at anode, always we takes the oxidation. At cathode, takes the reduction reaction. So Mg gives to Mg plus 2 means losing of electrons or gaining of electrons, losing of electrons. In which reaction will be takes the losing of electrons? Oxidation. So where the oxidation is takes place, that electrode is called as anode. So here clearly that in this cell magnesium is anode and other than other electrode is cadmium is cathode. Very simply, when you have to decide the anode and cathode, then you have to take the standard formula of standard electrode cell EMF is equal to E naught cathode minus E naught anode. What is the E naught? E naught standard reduction potential of cathode minus standard reduction potential of anode. But here given standard reduction potentials of two electrodes, simply you have to first of all decide the which is the anode, which is the cathode. Thus we have to take in that cathode and anode from the cell representation. So here cathode is cadmium. Its value is minus 0.40, and cadmium standard reduction potential is, and magnesium standard reduction potential is minus 2.37. So then you have to take minus 0.40 minus of minus 2.37. So then you have to take, automatically you will be get the 1.97 volts. Result will be 1.97. You have to mention either it is positive or negative. So positive, you have to get the 1.97 positive. That's why this cell perfectly generate the power. So this is a very simple. Within 1 2 steps only we have to get the result, but in which, when you have to fail to decide the anode or cathode, you will get the negative result, or you get the failure result, then automatically you will lose the marks. Okay, understood. Now next one, same you have to take the another one problem, the zinc electrode. How can you replace the zinc electrode? Zinc slash zinc plus 2. And copper electrode, copper slash mm, copper plus 2 slash copper electrode is. So here given electrode potentials. Here mention only electrode potentials, not either standard reduction potentials or oxidation potentials. Now you have to decide it, whatever there. So in the question only given electrode and electrode potential. So here zinc electrode potential is given plus 0.76 volts, and copper electrode potential is plus 0.34 volts. Then you have to calculate the EMF of the cell, which is represented as a zinc electrode, zinc plus 2, salt bridge, copper plus 2, electrode, copper. So in this cell we have to decide zinc act as a anode. Why? Because here zinc electrode, the zinc losing or gaining of electrons, you should be calculate. Zinc to zinc plus 2. What do you mean? Losing of electron. So where the losing of electrons at electrode, that electrode should be called as anode. So here zinc is called as anode. Other one is copper is called as cathode. So when you have to decide at the electrodes as a anode and cathode, then that here electrode potential is given for the zinc plus 0.76. This is the oxidation potential. For the anode, oxidation potential is there. For the cathode, reduction potential is there. So here for the copper 0 plus 0.34 volts is the reduction potential. Here plus 0.76 volts is the oxidation potential for the zinc. Then just now you have to take the, both are also reduction potentials to calculate the EMF of the cell. Otherwise, suppose in this whatever they are given that electrode potentials, by that also you have to take the formula for the one of the reduction potential, another one is oxidation potential. So whichever you have to take, that formula is depend on that values. So first formula is E cell E naught cell is equal to E naught cathode minus E naught anode. Whichever this formula is for the both are also reduction potentials, then you have to take the reduction potentials. Otherwise, another one formula is E naught cell is equal to E naught cathode reduction potential plus E naught anode oxidation potential. So here oxidation potential is plus 0.76, and then you have to add the plus 0.34. So here 1.1 volts, 1.1 volts plus 1.1 volts. Otherwise you have to take minus, then minus into minus also plus, then automatically you have to get the same value from the first formula or second formula. Then you have to get the result is plus 1.10 volts, which is that perfectly generated the power. So this cell was also generate the perfect generate the electricity. So next one problem is, problem number 3. Look here, the standard electrode potentials of calcium and lead plumb electrodes are standard reduction standard electrode potentials, not mention either reduction or oxidation. So now we have to decide from that problem. So minus 2.9 volts and minus 0.12 volts respectively. So a calcium electrode given minus 2.9 volts and lead electrodes are minus 0.12 volts. What is the EMF of the cell constructed from these electrodes? Just given two values, but not given electrodes, not given electrode representations, not given electrode cell. Cell was also not given. So here standard reduction potential of calcium is less than that of the lead electrode. So here calcium, lead both are also compare that which is the less, that one act has anode. When we have to observe that electrochemical series, from that electrochemical series topmost element is calcium, next one is lead. So that's why which is the topmost element, that is act as anode, and next one act as cathode. So here lead act as cathode and calcium act as anode. So then you have to take both are of the value sign, then automatically from the formula you will get the result. So E cell is equal to E cathode minus E anode. Here cathode is lead value is minus 0.12 minus minus 2.9. It will be gives the plus 2.78. So this cell also perfectly generate the electricity. And problem number 4. The standard electrode potentials of silver and lead are okay. Here given silver and lead. Silver and lead. Silver value is plus 0.8 volts and lead value is minus 0.12 volts respectively. Calculate the EMF of the following cell and state whether it is generated the electricity or not. Simply here given the cell whatever there Ag plus 2 Ag means whatever they are going gaining of electrons. So salt bridge and Pb plus 2 Pb here also gaining of electrons. So how many number of gaining of electrons depend on here in the given cell silver is anode. Silver is anode. Lead is cathode. Silver is anode. So when you have to decide the silver is anode and lead is cathode, automatically you will get the value. Then you will get the value in the negative form. Negative form. That's why this cell does not generate the power. Calculate the E. Problem number 5. Calculate the EMF of the cell if the cell reaction is chromium plus cadmium. Here cell reaction is given. By the reaction we have to decide the electrodes and which electrode act as a cathode and which electrode act as a anode. Given that E naught of the chromium is minus 0.74 volts and E naught of the cadmium electrode is 0. Minus 0.40 volts. In this cell the reaction chromium oxidized and cadmium is reduced. Chromium is oxidized, cadmium is reduced. So automatically chromium electrode is a anode and cadmium electrode is cathode. Simply you have to take the now standard formula is L equal to cathode minus E is not anode. Then automatically you put the values and you will get the result. Whatever the result is minus 0.4 minus of minus 0.74, it will be used the plus 0.34 volts. So which is perfect, this one also cell is perfectly generate the electricity. So and here everybody should understand what is the EMF. Electromotive force of a cell. The potential energy means nothing but either gaining capacity or losing capacity of an electrode is called the potential energy. That much energies are two different energies for the two different electrodes are there. Suppose your cathode and anode is there. For the cathode is reduction potential, for anode is oxidation potential energy. By these potentials, to difference, whatever the difference means, how much difference is there, it will be gives the positive charge, positive energy. Then only that will be possess the electrons from anode to cathode. Then automatically power will be generated. Power will be generated. That is called as the electromotive force. That is the electromotive force. So by the understanding of electromotive force, and you have to calculate the E cell, the EMF of the cell calculated from the electrode potential values. So here reduction potential, here standard formulas are there. You should be remember that formulas. Always be E cell equal to reduction potential of cathode minus reduction potential of anode. For the automatically for the standard values, you have to represent the E cell equal to E naught. You have to represent it with the E naught cell, E naught cell. And E naught cell, standard E naught cell equal to standard reduction potential of cathode minus standard reduction potential of anode. Otherwise, if we take the reduction potential of cathode and oxidation potential of anode, then you have to take the standard formula E cell equal to reduction potential of cathode plus oxidation potential of anode, and calculate the EMF of the cell. So this is the our session.